All right, so in the last video, we finished talking about the Church-Turing thesis, which is an extremely abusable idea that we are going to abuse repeatedly. In fact, it is going to be the main thing that we use in order to prove the incompleteness theorem. But it also kind of left us at a bit of a philosophical bend, because we had basically at least implied 3 different definitions of computability, and we were less sure than ever about what computability really philosophically is. We're pretty confident that we know what it is as far as human pen and paper computation, but what is it more generally than that? And so this video is going to be dedicated to talking more generally about computability. And I think the key to doing that in a way that's valuable lies with a trip over to the cybernetics people. Ashby is going to help us out with his concept of isomorphism. But before we get there, let's look back at the original thing. Remember, what is computation then? To me, it's this. Here's what computation is to me. To me, computation is a feedback loop like this. It's a feedback loop in which measurement is taken from the environment by a controller. So we've got this environment. That's the store that Turing was talking about. I'm going to replace the store, not with paper, but just with some abstract environment, the world, right? Measurement is taken from that by a controller. So the controller measures something in the environment, and then it makes a decision based on something it's trying to do. It then interacts and changes the environment that it just read from via some mediating force, via some mediating interface. And so that is what Turing called the executive unit. The environment is interacted with via this executive unit. It is changed, and then a new context is reached from another subsequent measurement from the environment. That, to me, is computation. I realize that some people would disagree and say, no, that's a control system, and that's different. And I'm not I'm not an expert on cybernetics, but to me, this really is the beating heart of what we are talking about when we talk about computation, because computation is physical, and this captures the physicality of it. The idea that I am not computing unless there is some component of reading from the environment. Even with the Turing machine, you are simulating an environment to read from. That physical environment is a core component of computation, and that's the thing that all the mathematicians struggled with, and it's what everybody still struggles with today, is that you can't really separate it. Here, this S is always going to be there, and I think it's essential to, you can't just take this box here and say that's computation. I don't think that's a good idea. This whole system together is what you should call computation. And if you get rid of this E and you just put a straight line down to here, then it's starting to look a lot like this thing that a lot of continental philosophers call, it starts with a D. I'll leave it at that. So what I want to do now is I want to look at some examples of this more generally. We've been talking about human pen and paper computation, and what I want to do now is I want to talk about other things that look like this feedback loop. That's what I want to do. And then I want to talk about the extent to which the fact that those other things look like this feedback loop, to what extent can we call that computation, and more importantly, to what extent can we relate that to a conversation about Turing machines? If I am proving things about computability via talking about Turing machines and any of those models, what are we saying? What is that saying about the real world? What is that saying about all the other physical computation that goes on around us? And that is going to depend on the extent to which we can relate real life things, real life physical computation to Turing machines. So that's what we're going to be doing here. So the first example is the simplest possible example. When I think of the simplest form of computation ever, I think of a thermostat, and I think you should too. Thermostats are the simplest computing devices. Thermostats do what? They control the temperature of the environment. And so here's how it works. Temperature is periodically read from the environment by the controller. So the environment is your apartment, right? There's a focus, right? There's somewhere in your apartment there is a temperature sensor, and that determines the temperature locally, and then you make a decision, a very simple decision based on the temperature. So if the switch is flipped to heating mode and the temperature is above the desired temperature setting, then it flips a switch and turns off the heater, presuming it was on. If it's below, then it flips the switch another way. If it's in cooling mode and the temperature is above, then it's going to turn on the AC unit, and if it's below, then it's going to turn it off. So it takes the temperature, it makes a decision, and then it interacts with the environment via the flipping of the switches. So the control here is the thermostat itself. The store is your apartment. It's your environment. And the executive unit are these two switches that it can switch on and off. It can interact. Those are the control. The thermostat's interface with the environment. The pencil is the switches, and it does that, and it just keeps doing that. It's just this. It's just we read the temperature, we make a decision, we flip a switch, and then we do it again. And hopefully, if it's working right, the person in the apartment will have no idea that anything is happening. And note, we can even talk about a focus. Remember, what I meant by focus is this particular location on the page that the controller is looking at. We have that here. What is it? It's the particular region of the apartment where the temperature sensor is located. It's just a focus that never moves. It just never changes. The direction stays the same. But that's all. It's all there. Everything about computation and Turing machines and pen and paper computation, that loop is present with a thermostat, and it's very obvious with a thermostat. In fact, what I like about the thermostat example is that's kind of all there is with a thermostat, is you only have this basic form, this basic skeletal form. Here's example 2. It's a pretty good one. It's you, right now. The store is the whole planet. The environment is everything. And the focus is what you see around you. It's your immediate environment and your surroundings. What you can reach with your hands, what you can feel with your body, and what you can measure via tools. You take these inputs into your brain. Your brain is the control. And then you make decisions based on that context. You have context based on your location in the store, the environment. And you make decisions based on that. I'm not going to get into the details of why you make the decisions you do. That would require getting into some psychoanalysis, some developmental psychology. It would require you to talk about desire loops. It would require you to talk about stimulus response, the pleasure principle, all sorts of things like that. But you get reading from the environment. Your body just absorbs information from the environment, and then it starts to change, and then you make decisions based on that. Or it doesn't start to change. It's just you make decisions based on what's happening. So you obtain context from the environment. Context yields action, and you alter it by whatever, and then you proceed to make a decision. Right? I make a decision to do something based on what I'm feeling and where I am, and that is a change. That produces a change to my environment. And it also constitutes a shift to my focus. Maybe I move somewhere, and and the executive unit is just whatever I am able to use to interact with the environment. Your mental state might also change. Obviously, I'm in a mental state. I didn't mention that part. There's a mental state for the thermostat too. What is it? It's the mode, right? Whether I'm in a heating mode or a cooling mode. Those are just mental states. And mental states in the second example are literally mental states. So my mental state changes. I read from the environment. All the components are there of this loop. Oops, getting ahead of myself. All the components are there of this loop right here. We can make this model more specific. It would probably be more responsible to do that. For example, we could focus on specifically the computable process of keeping yourself comfortable, right? I get hot and then I do something. The desire to phase out unpleasant stimuli and reduce them to zero. And again, there's something going on there too, but that's a control systems thing, so maybe I shouldn't get into that. Cyberneticists, or cyberneticians, or whatever they call themselves, tend to view all machines in terms of a flow of information, and they view the success of a machine as the ability to destroy information, or at least absorb, they would say absorb variety, which is kind of equivalent to destroying information. You take in variety from the environment, and then if the thermostat is working correctly, then nobody will notice that anything is changing. The thermostat's behavior itself absorbs the chaos. It absorbs variety. So cybernetics people will actually view machines abstractly as all the same, in the sense that they are all variety absorbers. They are all regulators of variety. But anyway, that's a whole nother story. It should also be noted, this bottom thing I mentioned, is that the number of states may be infinite. The number of mental states may be infinite. I'm not going to tell you that your mind is not an infinite realm of potential or some shit. But the number of actions is certainly not, and that might surprise you. You're sitting there watching me. You can do all sorts of things. There's a fluid collection of things you can do, right? Well, not really, right? I mean, suppose that you were in a room with me giving this talk. What are your options? Well, you have a vocabulary that has been given to you socially, and that vocabulary is more limited than you realize. You can talk, you can speak up and say something, you can get up, you can continue listening. If you break down the actions in terms of their real function, then you really don't have that many options at any given moment. In other words, the number of symbols that you can produce on the page with your executive unit is always pretty limited, and to the point where it's really not a stretch to say that the number of symbols in the machine is finite. The machine being your fundamental cognitive loop of existence. And so, in some sense, we have to concede the validity that your existence is a computation in the sense of this right here. So, there's that.